Tesla Powered TVR. Last time I saw it, it actually had a battery box in, and then within minutes, this gentleman over here, Dimitri, had taken the battery box away and taken it away in his rather nice Golf R.
Yesterday.
Hello, we're back on the TVR today. We are going to be taking apart the front battery box and seeing what we need to do in order to fix it. Last time we disconnected all the HV, so it's all safe. We've undone all the bolts, so we can take the cover off, take everything off, and then we're going to try to get the modules out and hopefully get the battery box out. Because if you remember, there was a massive hole down the middle of the battery box, which is for the cooling lines. We will try and fix that. Just use some through-hole quick fits for the lines. So I've got the HV bus bars out. These seem to be the OEM bus bars since they are flexible. As far as I know, only the MGZS OEM batteries had them in. Seems like they have bent it in a couple places, which isn't too bad. But the more scary thing is they've cut open the bus bar and you can see the layers which give it the bendiness. So it's able to bend because all the layers are so thin. But what that means is you have bad contact between the layers, which will create higher resistances on the bus bar. It'll heat up and it could cause a battery fire. So that's why the OEMs actually weld them, so you can still see the layers, but they are, I believe, friction welded together, and it's basically a solid piece of copper down here which you can just bolt down and you've got perfect connection to the battery. And then the long bus bar seems OEM as well. This heat shrink is an afterthought, and the other end has been cut open as well. So these two will need to be replaced. I'll have a think with what we can replace them. Create a solid bus bar. I've got a copper sheet and we can send it to a laser cutter, which can also bend our bus bar, or try and get a brand new bus bar from MG and see if it fits. So yeah, that's the bus bars. Moving on to disassembling the modules. So here we have the modules, the front battery pack. So this is a black module, and here's a black module with no cover on. And if we have a look at here, we've got the LTC6813 chip, which is a balancing chip for up to 12 cells, I believe, which perfectly matches our theory, where this is the master that balances this battery and the slave battery, since this only has connections. It doesn't have fuses, it doesn't have balancing chips. This is a straight out cell tap, whereas here we can see that there's a communication chip here, so isolation for the communication. We can see the 5-volt regulator, I believe, the LTC6813 chip with all the resistors and the MOSFETs to turn the balancing on and off for all the 12 cells. So there are some fuses on this board. So what we'll have to do is get these connectors off, create our own board that just acts as a cell tap going out with some SMD fuses. Here, same here. We'll just add some SMD fuses to this board. We'll keep the battery side connector. This connector will probably change to Molex, since it's super difficult to get hands on these connectors, since they're full Chinese vehicles only. So that's that. We have taken out the modules, so we've got thermal pads, which is nice. We've got the cooling plates, which are not mounted, so we'll have to figure that out. Here is the big gap in the middle where all the cooling lines are going, and if you can see, there's some rust spots already, so we'll have to clean it up, weld it in, and create a watertight battery box. We'll remove all the cardboard. As far as we know, it was used just to protect the paint, just to protect the Raptor. If we can, we'll powder coat it. If we can't, then we'll just throw a thick coat of paint, probably plastic dip or something like that, so it's not conductive, and maybe get some Kapton tape, or I believe there's Mylar paper that is non-conductive as well, and it's fireproof. I managed to undo all the bus bars, so all the modules have been singled out, or there's no HV at all. These are 6S modules times, let's say 24 volts. They're less, probably like 21. All of these are safe. This is very questionable. Thermistors, I'll have to get rid of those. We'll have to take out all of the modules, just because they do have the thermal pad under there. So we have to rescue that, take out all the cardboard, because inside the battery box, that is a fire hazard. Get all these boards out of the modules to replace it with ours. Probably want to take all the modules and the cooling plates and the contactors out, because we're going to have to be drilling more holes here so we can secure the lid nicely. And again, I think we could take a bit of it off. It's not necessary, but might be useful to save a couple of kilos. And then some of the bus bars are questionable again. I've got all of them at the front. So, oh, let's start with the interesting one. That doesn't look like good enough surface area. For HV, there has to be a minimum surface area, the cross-sectional area, sorry, for the HV, because all the wire acts like a resistor. And just to be safe, they're built bigger so they don't heat up. This is all fine. Then we come to the first interesting bit. That looks like a bolt. So there's a bolt connecting this bus bar to this bus bar, and then there's another bolt connecting this bus bar to this bus bar. Again, this has been probably a DIY bus bar, which is fine, but yeah, these are questionable bus bars. It is this one especially. All this electric tape, probably a whole roll of electric tape. We've opened up all the packs, all the modules, taken out all the slave and master PCB boards from the top. So now we just have connectors left where they should be going. So that's all good. So from the rear battery pack alone, I've managed to scavenge all of these boards. So I've got 1, 2, 3, 4, 5 masters and 5 slaves. For the masters, the connectors that I need to scavenge are these 10 pins. One master makes one standalone PCB, whereas with the slaves, they've got 2 of the same connectors either end. So, and because the VASS boards only use one connector and the other one is, I believe, Molex, we can actually make 2 for the 2 slave modules from one original. So we'll have to find more of these boards. We'll probably contact the previous shop just to see if we can get those back in any shape or form. We just need the connectors, so I can desolder them, solder them onto the VASS boards and just populate all the modules, and then from there we can do a nice cell tap loom with all the thermistors. We'll probably just use the, I want to say it's 8 thermistors per BMS, which should be plenty, and then fix up bus bars, figure out what's happening here, figure out if we need CCS. If not, great, we've got 2 contactors left over for the future of CCS. I might actually leave the contactors there, just cover them for future CCS. Yeah, it's all coming along nicely. It's just taking some time. This will be coming with me. So we have the battery modules out, cooling plates out. What can we see? So there's a massive hole down the middle, and then holes for the cooling plates to mount to. Yeah, there's a few questionable areas like this. I don't know if you can see it, where this edge has lifted up. So we'll have to inspect that. But yeah, it's not too bad, but could be better. Let's put it that way. What else do we have? Got all the battery modules out, got the cooling plates. So some of these are fine, just need to wipe them down. Some of them, they have been they've got some paint on them. Some are worse than the others, so I'll probably take a wire brush or something like that, try to get rid of that, just because we want as much surface area and clean contact to the aluminium itself. So we've got the best thermal transfer. So yeah, let's try and take out the battery box. So managed to somehow get this rear HV junction box out. It's got hardwired connections of the HV, which is okay. Question is, where are the other sides of the glands? Oh, there's the cable. Okay, so we can get them out. And then I found the Tesla motor. So here it is, hiding under the front, mounted sideways, going out to the rear. So now I've got the last 4 bolts, I believe, for the front battery, and then that can come out, and then with that we'll have to think, because these 2 boxes connect to each other. This one has the BMS and the HV lines, and it goes into there and to the modules and so on. We have to make this watertight. Now, there are a few ways of doing it. The easiest way that I can think of is weld this to that and have some Tiger Seal between them. Just slap a ton of Tiger Seal, because all these faces they've got their own mind. Or, since the bolts are under here, we will have to figure something out. Remaking the battery box, I wouldn't really want to do, but it might come to that point. This battery box needs a bit more thought, but it is what it is. Also, all these holes for the top lid mounting in, the moisture, water can go down the bolt into the battery box, so on. What I'll probably do is, you can get some captive nuts that are not hollow, so they're not hollow through the whole way through. So that might be an option. That will be sealed with a bit of Tiger Seal or RTV. Or if we can, it would be nice to make a gasket so we can take off the lid easily. So this rear bar holds the back of the battery box. So there's a bar across there, bar across there. It's all triangulated, which is all cool. Cool and nice. But for this box, there is no bar at the back, which means that the only way this is mounted or holds itself up is it bolts to the battery box. So we will probably have to fix that, and by fixing that, I think we'll have to probably just weld on some square bar over here and put some studs on the bottom of this so it can slot down, bolted up from the bottom. It will be a bit difficult to access, so I'll have to think of the best way of doing it. Having a look at this again, there is a single radiator for both the motor cooling, inverter cooling, front battery pack and rear battery pack. Now that's a Tesla Model 3s do that, but that's because they have valves and they can actively cool the batteries. And if they need to heat up the batteries, if the inverter loop is hot enough, they turn a valve and the warmer coolant goes into the batteries to warm them up. But here, there might be valves somewhere, but figuring out how to program that, how to wire that, is such a big task that it's easier on these EV retrofits just to run 2 individual radiators. One for the motor, one for the batteries. They are going to be running at different temperatures, and because they're going to be running at different temperatures, you want to separate them. You don't want to heat up the batteries unnecessarily. The sweet spot for the batteries is 22 to 25 degrees Celsius, and the Model S inverters are less efficient than the Model 3s, so they create a bit more heat. So the inverter is going to be running hotter. Usually I've measured these and they run about 40 to 60 degrees Celsius. Again, depends on driving, depends on the car. This is a lightweight car, so it might be cooler, but we do not want to find out and then try and fix it. We want to make it right since the start. So what I'll do is probably order another radiator and either put it behind or just have 2 radiators side by side. Bigger one for the motor, small one for the batteries. And that should be sufficient. So mechanically, the motor is mounted solid. So there's a plate here, it's welded down to there, and then it's bolted to the chassis, so that's all good. So motor mounts, that's fine. It would be nicer to see that it's got bushers, so the motor can flex, just so it doesn't kill the transmission, the rear diff, and so on quicker, but that'll do the job just fine. The next thing, the inverter is mounted in a good location as well. This 3D printed box is questionable, just because I can see, what can I see, that during a 3D print it lifted some of the corners, which means that whoever printed it probably did not care, or it was cold when they printed it. Again, it's not a big thing, but since it's a 3D printed, very thin box as well, it's probably a mil or 1.5 mil thick, and then that's the ground, so any rocks hitting that 3D printed piece will go through and they will end up in the inverter, which is the last thing you want to do. So we'll have to figure out that as well. Probably just add a metal plate in front of it and I'll do it. And then yeah, all the wiring, all of this mess. This doesn't have to be 2 miles long, so we'll have to clean that up. And then this is the inverter encoder cable, which is, so this is the inverter motor cable, which is very important at running EV motors, so it knows which phase to turn on next, field weakening, and so on. If this gets chopped or it loses the signal, then what I'm guessing is the motor will go into safety shut off, where it connects all 3 phases to each other, which basically means the maximum regenerative braking the motor can give. Each phase will be connected to each other, thus shorting out, and it'll just lock up the wheels on this car. So again, have to secure all of that, figure out this mess, make it nice and tidy, presentable for whenever we go to car shows. All the bolts should be undone. Let's try and get it out. Okay, we're halfway there. That's good. And then, oh, this would be a nice 2-piece. Let's go. I believe what I want to do with the battery box, I want to remove the floor, since it needs to be welded in anyway, and so on. But the nice thing is, so this is the line where the cooling plates used to be. There was a small gap and a bit of a gap for the cardboard. This BMS would nicely fit in there. So there's a bit of space, and if we need to remove the heat sink, so be it. These heat sinks are there just to increase the thermal mass. There's no thermal paste between it, so it's, if the aluminium case of the BMS gets warm, this gets warm as well, and so on. Since there's no airflow going over it, it doesn't actually do that much. And since it's such a small unit, there's only 36 cells in the front. It's not going to have enough heat coming out of the balancing resistors to actually require the heatsink. So I think what we can do is remove the heatsink and mount the BMS in a corner. That means that all our cell taps can be left in the battery box if we need to remove it somehow, whereas previously everything would go through the hole, and so on. So we can do that with the BMS, which means that out of the second box we have taken out the BMS. So all this space was just BMS. What we are left with are the 2 contactors and 3 HV lines. That all can be squished down. So contactors can be moved closer to the front of the car, and the 3 HV lines can just be behind them, since they come out on top of it anyway. We'll have to think about the minimum bend radius and so on. But if we can reduce this box down to just here, we can move the whole box over here and just weld it to the front battery box. That way it will be weatherproof, and we still have access to our mounting points, the original mounting points. It'll clean up the engine bay. There's going to be less space taken. So for example, I don't see an expansion tank. That'll have to go somewhere. A nice place to it would be in that corner, let's say. And with the updates we can actually do that, whereas right now there's no space. So I will be taking the battery box BMS cooling lines, cooling plates and 2 BMS battery modules with me, and there seems to be quite a few black ones that don't have the holes cut out, which is nice. So we'll try that, and if I don't have enough connectors, we do have another 2 grey modules with these connectors, and from what we see we've got plenty of these weird and wacky Chinese connectors which we can use on the other PCBs on our circuit boards, and have enough modules, enough boards for all the modules, so they're just stupid dummy modules with the cell taps. None of this magic in the background. And that, ladies and gentlemen, is one empty battery box. What can we see here? Oh, that's nice. So they've used the split kit for the Tesla Model S, which moves the inverter from the motor, which would have been on the other side, to basically any location you want, as long as you're running the 3 phase cables, which are down there. So we can see that down there you've got the phase cables, and they just go into the motor. And yeah, that's how you build a remote inverter Tesla motor. Yeah, there's a lot of slack in all the wires. Yeah, we'll have to clean all this up before we put the battery back in. Then we've got a questionable right angle for the cooling. I do not know why that is a right angle and why that can't be straight. That seems to be going out of the motor, so just a straight pipe. I'll probably replace that with a straight piece, because that has been, someone made that. That's 2 pipes welded together at an angle. Questionable again. We'll try to get rid of as many questionable things as we can. I am guessing this tank is for the oil cooler. Sorry, for the oil in the gearbox of the motor. Yep, and then I think we found a oil pump, since the Tesla Model S motors, the older ones, they've got mechanical oil pumps. The later Model 3s, Model Ys, even Cybertrucks, all of them have electric pumps. The Plaid, the Tesla Model S Plaid, on the rear motor, it's actually got 3 electric pumps for the oil. Yeah. Oh yeah, we found the manifold for the battery cooling. So that splits one channel of the water cooling into 4. So you're cooling the batteries in parallel. It's not a bad idea, but for the complexity of it and the fact that these batteries probably won't heat up that much, means that is kind of useless. So we'll have a look at it. If it's well made, we'll leave it, but then again, we'll have to figure out how to run 8 cooling channels in and out of the battery, which is 6 more than I want. I want as little amount of holes in the battery box as we can. I have run a 83 kilowatt battery pack. Well, it was a split battery pack just like this car, a third at the front, and the in and out tubes were this, and then we run the cooling plates in series. The temperature difference we saw was about 3 degrees between the hottest cell and the coolest cell, and that was between the front and back pack, so it's not a massive difference. And with these cooling plates anyway, it would be beneficial to have a chiller on board as well, so you can actively cool the batteries, but since that's not an option here, we'll just have to run with whatever we have.
12 seconds later.
What's going on, Dimitri? What's happening?
So, if you remember, the old battery box had a big hole down the middle. Obviously, that's an issue for weatherproofing and so on. So I decided to take it out and re-weld the bottom and fix up some holes. So there's a hole between the rear box and the front box. I'll try and get rid of this box altogether, so it's just one complete sealed unit.
Right.
Which, that's what I'm working on.
So I don't think we showed it in the last video quite clearly enough, but before there was it 2 channels going down here?
It was one channel down the middle,
Yeah.
where all the cooling lines went down
Yep.
to the manifolds that we see. So now I've cut out the floor, re-welded it with thicker piece of steel.
Yep.
And also it's flush with the angle bars.
Okay, yeah. Nice.
So that should be a nice flat bottom there.
No one likes a flat bottom, unless it's in a TVR. But and what are these for? These are for the...
So these studs are for the cooling plate. So you literally just drop the cooling plate and put a nut on the end.
Nice.
And that's it.
And yeah, there's the hole that's been welded up as well. You also mentioned something else that you're doing that is going to be different to the previous build, because something that previous garage took quite a long time on was the manifold for the coolant lines.
Yes, correct. So
What are we doing instead?
So we'll get rid of those manifolds.
Yep.
Just have a single inlet and an outlet. So this could be our fixture for the battery box. Just a barb fitting here, which clamps onto the hose, and then a quick connect, which clamps to our plastic hoses inside the battery box.
There's quite a few things that I've not seen here before. So that is a water pump down there, right?
Yeah, so that's the big water pump for the inverter.
That's the big one, yeah, and that's the inverter there, obviously. That's the Tesla small drive unit. And these are the smaller pumps, are they?
Yes,
This one?
so those smaller pumps go to the individual battery boxes.
Right, okay. Because there's 2 in the back, isn't there?
Yes.
I think so, right
Yeah.
underneath at the back. Yeah. No, cool. It's good to see it without the battery boxes, just so not only myself but everyone else can see what's going on here. So yeah, what else is going on, Dimitri? Oh, what's this over here?
Oh yes.
I spot a VASS logo.
Yep.
Nice.
So that arrived just today. So the idea behind that is, since we can't use the MGZS modules without the boards, the cell taps, we have to replace them.
Yep.
So this is the original master board. So it does all the balancing over here, all the resistors.
Yeah.
We don't need any of that since our BMS does that. So what I have designed is a drop-in replacement, so it goes this way around.
Yeah.
This board with all the connectors and the fuses just drops in place of this and gives you access to all of the cell taps and the thermistors. And the same idea here, just adding a bit of protection with the fuses.
Yeah. Nice.
So the plan with the battery box, the front battery box, and this auxiliary box is to join these 2 together, to weld them 2 together, so that there's no way of water or other debris to get into the battery box. So there was the old hole over here, which we patched up, and then I've drew these lines over here, and over here is where there's free space, because the mounting tabs at the back of the battery box, which sits on top of a square bar that's connected to the chassis. So this area behind here we want to leave free, so that we can install the battery box and take it out if we need to, which leaves us with all of this space, well, all of this space to play with. Now the only thing left at the back of here is there's 2 contactors, which in themselves maybe use this much of space, and then there's 3 wires going in. Now the wire size, I might be mistaken, but that looks like maybe 50mm without the sheathing. So yeah, for some reason these are coming from the bottom. In our case they could come from the side, or if we are coming from the side is probably the best solution for these, or we could put a connector on them. That way
We don't have to worry about if there's voltage on them or not, since we can create our battery box with the cooling plates, modules in, BMS in, all the cell taps done, all the HV connected as well, and just when we need to take it in or when we come to put it in, we just plug in the connector with the 3 wires and that's it. Make the box smaller by at least maybe there, so it will be a lot narrower. Also, it does not need to be as high, so it could drop the height to just this, which will enable us to create a single lid for the battery box. Now, to stop this wire is going from the inside of the battery to the outside with no weather protection, I will probably end up using these HDP connectors, these Deutsch connectors, yeah, HDP26. So it's got 21 DTM pins, so it's the smallest DT pins. Each one of them can carry 7 amps, which is more than enough for all of this and the contactors. So we'll use that probably on the side again. For the low voltage, I found these fittings, so we can get a bob fitting on one end and just clamp the pipe onto it, and then the other side we can actually drill a hole in the battery box and pass the fitting through it and then tighten it down, and then it's a quick fit, the same diameter as on the cooling plate. We can again eliminate the connection and disconnection of the cooling plates inside the battery box, like the old style used to be. So that's another thing that we'll add. And then for the HV, I will try and find a 3-pin connector, probably going to the side, because it only has to go to the contactors. That's where all these connections were, at the contactors. So I'm guessing one is main negative or main positive, and the other one's the intermediate contactor. Okay, so that's the plan. This is going to be the new width of the rear battery box, the auxiliary battery box, which houses the contactors and has all the connections going into it. So that will be welded on the back of this battery box, and it'll have a nice channel to go through. The height of it will decrease because there's no point of having this as high as it is. It did house the BMS, but since we've managed to move the BMS over here inside the battery with the battery modules, there's no need for it to be that high. So we can easily chop this down, not as high, not as wide, and we'll just weld it on the back of this battery box, so it will be a lot closer.
So Dimitri, what's going on? I see that you've installed the battery box again. What's happening now?
Yeah, so now I'm just trying to figure out how to join these two boxes together.
Oh, okay.
Yeah, just to make everything watertight, weatherproof, and just as nice of a layout as I can.
What's the reason for what you're doing right now in terms of changing it?
So mainly I just want to simplify the design and make it as ergonomic as possible, and also give you some space back. Right. So there's the washer bottle here, which is hidden behind all the wiring. There's the, I'm guessing this is the oil fluid for the motor,
yeah,
for the transmission. So it's just all cramped in one space, and if you need to change anything or add the washer fluid, you can't now. So I'll try and give you back all of this space so you can space out all the rest of the components,
yeah,
and just make the battery box nicer. So you're going to have a single lid for the whole battery box, whereas right now it's 2 lids. Then this box has to be bolted to this box. All the sealing problems, there's just solving problems.
And you said also something about the reducing the number of HV cables.
So for some reason they did have 5 holes,
Yeah.
So there's the other 2 holes and an extra contactor. I'm guessing that's for the DC fast charging, the CCS.
Right. Yeah.
And as far as I know, there isn't any CCS on this car.
I don't think we've got the controller for the DC to DC. So I think the main aim at the moment, although DC charging is something that I really want on this vehicle, getting it up and running is the first step, really. It's, as everyone can see, you know, it's a work in progress. And Dimitri is working through it as he's going, trying to make improvements